Hi, I'm Jessica Cruz, and I'm doing my text correction for problem 7. And I'll start off by doing part A. Okay, so what I usually like to do for these, just because I get like very jumbled up when I like read all of this, I like to just write out my values. So my first one would be mass, which is 25 kilograms. Constant speed, of 2 meters per second, and I know if I have a constant speed, then that means my acceleration is equal to 0. And to do so, pushing force, I'm at an angle of 30 degrees below the horizontal, and I know I have friction, static, and kinetic, so my coefficients for static is this, and my coefficient for kinetic is this. Draw a free body diagram or the physical diagram with forces. Make sure to mark and label all the forces acting on the box. Okay, so for this one, I like to break it down into 2 parts just because I can't like do it just directly on the free body diagram. I actually like to draw the picture to kind of like see what I'm doing and if it's kind of right. So I have my floor and then my box, and this is 25 kilograms, and I know this has force normal going up and force gravity going down, which is equal to mass times gravity. And F push is applied to the box at an angle of 30 degrees. So I'm gonna do it right here. My angle of 30 degrees, and this is gonna be my F push. And then the thing that trips me up on these problems is like kinetic and static friction. I thought that both of them went on there no matter what, but now I understand that since the box is moving, we're using kinetic energy. So I'm only going to label my kinetic force, which will go here. So this is how my picture looks, with force normal going up, force gravity going down, and F push going below the horizontal at a 30-degree angle. Oh, can't forget my acceleration going this way, which is equal to 0. And then I'll draw this now into a free body diagram. So this dot is my mass. My FG is going here. Force normal is going here. And this is below the horizontal, so this is like my x-axis. So it's going like this. F push. My angle theta here, which is equals, my angle theta is here, which equals 30 degrees. And my force kinetic is going this way. Since I have an angle here, I have to figure out which one would be F push sine of theta and cosine. The trick I like to use if it's getting smaller as the line is approaching the axis, it's cosine, but it's getting bigger, it's sine. So in this case, this x-axis would be F push, I believe cosine of theta, and this one right here would be F push sine of theta. Okay, so that's my first part. That's for A. And for this part, I understand that the part that like messed up on was just labeling my coefficient for static, because again I get very confused. I thought I had to label them both no matter what, But now I understand if like the box had no motion, that's when I would label my coefficient of static or my force static. And since this box is moving, it's like getting pushed, I'm using my force kinetic. Okay, and then for part B, okay, we're good still. See it. Well, I keep pushing, how much force do I need to apply to push this box at a constant speed of 2 meters per second? Okay, so for this part, I'm gonna do the x components and y components. So x component, so it'd be F net of x equals ma of x. And then looking at my free body diagram, we're looking at the x-axis. So before that, I already know the acceleration is 0. So if acceleration is 0, 0 times anything is 0. So this whole thing cancels out and it equals 0. So my net of x is equal to 0. So now it would be F push cosine of theta, and I'm gonna just put FP so I don't have to write everything down. Oops. It'll be minus my force kinetic. And since I got that, and I'm trying to figure out for my force push, I'll just move my force kinetic to the other side. So FP, or force push cosine of theta, equals force kinetic. And then I already know from my phone, the equations that we got. Yeah, they're right here. So yeah, force kinetic is equal to the coefficient of kinetic times force normal. So I'm gonna just put that up here just for now, just to write down my my equations. And just because I tend to get very confused when I have like a whole bunch of stuff here, I'm gonna just circle the equations I have right now. So I have my x components, so I'll do my y components now. So F net of y is equal to ma of y. And again, acceleration is 0. 0 times anything is 0. So this whole thing is 0. So it's going to be F net of y equals 0. And the reason it's 0 is because there's no acceleration in the y direction. Since this box is on a horizontal line, it's not on like a ramp or anything. Or like if we were doing pulleys, that would have been something different. But since this is just on a horizontal, and it's just the box being pushed to the right, we only have acceleration in the x-axis, and in that case it was 0 also because we had constant speed. But now I'll do my y component. Okay, so now I'll do my y component, and that would be force normal minus mg, so mass times gravity, minus F push sine of theta, and it equals 0. Okay, and that would be my equation that I have for my y component. Now I have 3 equations, and I have to figure out how to move them around to how to use my equations. So I know I'm looking for force. So this is what I started with, the next component. So since I have FK here and FK here, yes, I'm going to replace this here. So I'll write this up here. Force of push cosine of theta equals Fk, and Fk gets replaced, so now it's going to be F cosine of theta equals this, coefficient of kinetic times force normal. Now I need to look for my equation for force normal, and I'll look at my y components now, and I could just move this to the side. So F normal equals mg plus F push sine of theta. And now this is my other equation that I have, and now again I could place this in here for this, for my unknown. So now my new equation will be F push cosine of theta equals the coefficient of kinetic mass times gravity plus force push sine of theta. And so now I'm going to distribute this like this. So now my new equation again would be coefficient of kinetic times mass times gravity plus my coefficient of kinetic force P sine of theta. Yeah, okay. And since I'm trying to find my force push, I'm gonna move anything that has that to this side. So that'll be this. So I'm moving this to the other side, so it'll be force push cosine theta minus coefficient of kinetic force push sine of theta equals this. And this is my common factor, so I'll take that out and I'll rewrite it like this. Force push cosine of theta minus this and sine of theta equals mass times gravity. And then if I was just to multiply this out, I'll get this cosine of theta and this, and like the p back, force push. Okay, now since I have this, and again I'm trying to look for force push, I'll just divide it. So cosine of theta minus sine of theta, and this will cancel out. Cosine of theta minus sine of theta. Now this is my equation. Cosine of theta minus sine of theta, I believe. Yeah, so now I'm gonna use another sheet of paper. So now I'm going to plug in my numbers. So my coefficient of kinetic is 0.2. My mass is 25 kilograms. And my gravity is 9.81 meters per second squared. All divided by cosine of 30 because that's my angle, subtracted by my kinetic coefficient, and sine of 30, which gives me .03 newtons. So therefore, what was the question asking again? It was asking how much force do I need to apply to push this box So F push would be 64.03 newtons. And where I went wrong here was because in my free body diagram I labeled my force static as well as my force kinetic. That was one thing that messed me up, because here I have force kinetic minus force static, where here I just end up with force kinetic. So that's less work for me here. And I did do the formulas here, but I only needed force kinetic, not force static. And my y component wasn't affected. And I got the same thing here and here. Sorry, here and here. And I think what messed me up the most was just like not labeling my free body diagram right, because I did put the force static in here. So I had to try to solve for that. And while doing all of that, like, I couldn't really see clearly what I was doing. I got a little bit confused here because I didn't know how to move this sign for sine of 30 over here. And that's because I divided cosine of theta way too early on, compared to here where I kept everything how it was supposed to be, like force push cosine of theta, and then I kept distributing what I had to. And that's when I could clearly see that this also has a force push and there's a force push here, so I could move this onto this side. And that's where I was able to see I could just pull out what was the same in this, which was force push, and put what was left in parentheses, and then I was able to divide it by that. So that's the part that got me, was the part where I divided my cosine of theta way too early on, and I just didn't know how to solve this anymore. Where here I kept the cosine of theta there, and I was able to see more. I was able to see what I was supposed to move to the left side and what I was supposed to do there. But that was part B, and now part C. Okay, so for this one, I didn't do this question because I was trying to do part number 8, and that was taking up too much time, and I kind of knew what I was doing here, so I decided to like spend more time on this rather than trying to get this done and getting it completely wrong. And I also didn't really know what this question was asking, because I forgot that there's a difference between like the friction force and the net force. And I didn't do enough practice with using kinematic equations. I focused on like the pulleys and the ramps more than this, so that was on me. But now I feel like I have a better understanding of what to do. Okay, so again, I'm gonna just rewrite my information that was given to me. I just like to do that, so I could keep it here just in case. Constant speed. My angle is 30 degrees. Okay, so now I want to test the strength of the friction force when the box is moving at a constant velocity at 2 meters per second. Next, if I stop pushing, how far distance will the box slide before I come in rest? In other words, calculate the stopping distance. Okay, so for this one, I know the initial speed was 2 meters per second, so I'll write that down. And I know my final speed is going to be 0. Because coming to rest. So that's going to be 0. So This would be my final velocity, and this would be my initial velocity. I don't know if I'm saying that right. I'm sorry. Yeah. My final velocity and my initial velocity. So from here, okay, what I like to do is just write down F net equals ma times a.